Hello everyone. Today we will talk about the fundamental trigonometric identity. Let me remind you of the definition of trigonometric functions of an acute angle. Let's consider a right triangle with legs of length A and B. This is the right angle, and hypotenuse C. Let alpha be an acute angle opposite to leg A. Then, by definition, the sine of alpha is sine alpha equals A over C. The cosine of alpha, cos alpha, equals B over C. The tangent of alpha, tan alpha, is equal A over B, or sine of alpha over cosine of alpha. The cotangent of alpha, cot alpha, equals B over C, over A, or cosine alpha over sine alpha. And on the other hand, it is 1 over tangent alpha. The secant of alpha equals C over B, or 1 over cosine alpha. And cosecant of alpha is C over A, or 1 over sine alpha. Let's find the sum of the squares of sine and cosine of an acute angle. We have sine squared of alpha plus cosine squared of alpha equals A over C squared plus B over C squared, which is A squared plus B squared over C squared. According to Pythagorean theorem, the sum of the squares of the legs equals the square of the hypotenuse, so this expression equals 1. Thus, the sum of the squares of sine and cosine equals 1. Sine squared alpha plus cosine squared alpha equals 1. And this is the fundamental trigonometric identity. If we divide both sides of this identity by cosine squared alpha, we get another form. Sine squared alpha over cosine squared alpha is equal to tangent squared alpha plus cosine squared over cosine squared is equal to 1. And on the right hand, we get 1 over cosine squared alpha. Likewise, dividing both sides by sine squared alpha, we get cotangent squared alpha plus 1 equals 1 over sin² alpha. These two equalities we can rewrite like secant² alpha minus tangent² alpha equals 1, and cosecant² alpha minus cotangent² alpha equals 1. Thus, we can write the fundamental trigonometric identity in three forms, using sine and cosine functions, then secant and tangent, and cosecant and cotangent of them. In conclusion, the fundamental trigonometric identity can be used to find any trigonometric functions of an angle if one of them is known. For example, if sine of alpha is 3/5, then we get cosine² equals 1 minus 3/5 squared, which is 1 minus 9/25, which is 16/25. Then, and we can say that cosine of alpha equals square root of 16/25, which is 4/5. Since alpha is an acute, cosine is positive, and then tangent of alpha equals sine/cosine, which is 3/4, and cotangent alpha equals the reverse tangent, which is 4/3. Bye, see you later.